Good afternoon. Thank you. What a wonderful, wonderful crowd, and thank you so much for coming out and being here today. My name is Daryl Smith. Have a couple jobs at Microsoft. My first job is I'm the Director of Facilities and Energy for the corporate campus in Redmond. So with that job, I make sure the lights stay open, doors stay on, pay the utility bill, and manage the campus. My other job is I'm the Global Energy Manager. So I touch all of Microsoft's properties one way or the other. And my hope is today that my presentation is half as exciting as my flight in and out of Wellington on Tuesday. If that happens, I'm going to call that a huge success. So I've first time in New Zealand. Thrilled to be here. I've had a chance to visit Christchurch, tour the Red Zone, talk to officials there, go to Wellington, talk to city officials there, and talk to several of our customers here in Auckland. And what I'm doing is telling a story, telling how we're using IT across our portfolio to change how facility management is being done today. So what I want to share with you is some of the parts of the story, show you some screenshots, and tell you how we are doing this. So if you're not aware of Microsoft, we have committed to going carbon neutral in our fiscal year 13, so that's last June. And our corporate sustainability group has 3 pillars of how we achieve that. It's be lean, be green, and be accountable. And under these pillars, there's other tactics. And in these tactics that align to these pillars, there's 2 that are important to me. One is setting targets within our buildings on energy conservation. So what our goals are, what are we going to reduce. The other is we charge a carbon fee. Don't want to call it a tax, it's a carbon fee. If anybody within the company travels, has a building, has a lab, so I'm actually getting a fee for my flight here to New Zealand. And the money that's created helps buy high quality energy, renewable energy certificates, funds energy conservation measures. And if you think about Microsoft's carbon footprint, 40% of the emissions that are in our carbon footprint are from our real estate portfolio. 50% of the 40% actually come out of our headquarter campus in Redmond. So we're incentivized not only from an energy standpoint to do the right thing within our buildings to optimize it, but we're also incentivized to do the right thing to lower our carbon footprint. So if you think of the smart buildings or building systems opportunity, buildings around the world, this is commercial industrial buildings, consume 40% of the energy. There's over $2 trillion, and this is US dollars, spent on energy each year. And the last one here is a building could be wasting 15 to 30% of the energy in the owner occupants property management would be unaware. This was true for us as well. So for Microsoft, we're divided into regions. So we have Puget Sound, Asia, Americas, EMEA. So overall, Microsoft, our footprint is 3.2 million square meters. Half the real estate in Microsoft sits in Puget Sound. I say Puget Sound, Redmond, it's synonymous. It's the largest contiguous corporate campus in the world. And we own a majority of the buildings. So if you think about the Puget Sound, or in talking about the Puget Sound campus, just to give you a little high-level facts about the campus, it's 145 structures, 1.4 million square meters, 15 million square feet, 500 acres. We have 58,000 people that come to work in our campus every day. So actually the town of Redmond, the population doubles every workday. We have multiple disparate systems, and I'll explain why that's important. And we're 100 megawatt peak. So the grid that we're served off of serves 1 million customers. We're 3% of that grid. So we can actually move the needle how we start and stop our buildings. We spend $60 million annually in utilities, and we're in the 3rd lowest energy cost per unit state in the US. So very cheap power, primarily because it's hydro. So that's a great sustainable story. The interesting part here is we're connected to 2 million points across all the infrastructure of our campus. So this is your air conditioning, your power monitoring, your lighting, And all these data points, it's 2 million points, and over a 24-hour period, we collect 500 million data transactions. And historically have done nothing with that. We discarded it, we deleted it, we overwrote it. And this was our problem statement, is we have this wealth of data, and how could we use this to better optimize our campus, to provide us insight that didn't exist before. So this is Microsoft 1984, 88 acres. These are some of the first buildings. We call them the star buildings. In the center there, that's called Lake Bill. Legend has it that on every product launch day, the people would jump in Lake Bill. They don't do that today, for all I know. And this is West Campus. West Campus is one of our latest developments. And something interesting happened between the star buildings and West Campus. There was a phenomenal amount of construction in Redmond. There were cranes everywhere, and there was trying to meet, this is during the growth phase of Microsoft, and they were trying to meet the demand of the business. So at that time, we actually had 3 people in every office. So we were cozy. And there was a lot of pressure on the real estate team to deliver space as quick as we could. So we had general contractors putting up buildings, developers putting up buildings, spec buildings. We were acquiring buildings and fitting it out. Everything we could to get the real estate growth. And the challenge is while we built sustainable buildings, we built energy efficient buildings at the time, we didn't have this binder that said, here's what a Microsoft building looks like. Here's the specifications. Here's what we want for equipment, technology, and performance. And a consequence of that is that general contractors, developers, they built what they thought was best. So if one OEM or equipment manufacturer couldn't meet the schedule, they went to another, and then another, and then another. And a consequence of this is, if you ask me what type of system or what type of manufacturer, what type of aircon manufacturer do we have in our campus, I just say yes. We have every make and model you can possibly imagine. In fact, our parking system for West Campus is from Italy. Must have been a sell on parking systems that year. So it just happened, and it's just a consequence. And it's very difficult to manage a 1.4 million square meter campus at scale with all this disparity. It's just very difficult. Well, quite frankly, this isn't a Microsoft problem. This is an industry problem. The industry is building, and I say industry, construction industry has been building buildings the same way for the last 30 to 50 years. Everyone builds in silos. You don't have any way to aggregate. It's disparate. So in the construction meeting, we have what we call coordination meetings. And you would think that that would be the suppliers talk to each other and integrate systems, and it'd be a wonderful life. Our coordination meetings, quite frankly, are, hey, I'm working over here on this side of the campus. Nobody come over here. Well, we're working over here. Nobody. That's a coordination meeting. Totally misses the point. And so for our campus, on the air conditioning system, if I make a change at the building level, at the campus level, I have no optics. Did I just increase performance? Did I degrade it? Am I costing more energy, or am I saving energy? All our power monitoring, all our meters across the campus, our reporting is done by hand. So in the carbon reporting, in the chargeback, we actually spend 80 hours each quarter aggregating the energy consumption of all the labs, all the buildings. We go down to the PDUs, UPSs, and all the infrastructure, port it to a CSV file. 80 hours every quarter to tell our business groups where all the energy goes. We're Microsoft. Why do we have that level of challenge? Why is that not automated? Again, this is an industry problem, not a Microsoft problem. So our vision was, how do you take all this disparity and put it on a common platform? There were 2 ways that we could do it. One, we could do a rip and replace, where we get rid of all the existing systems with one system. And that was about $60–70 million. I would be the most unliked person on the campus, because I'd have to have building shutdowns, lab shutdowns to change out the controllers in the system. And quite frankly, it just didn't pencil out. I sit in finance. Anything we do is anchored in a return on investment. So that wasn't going to work. The other option is to use software to extract data of all these disparate systems onto a common platform. It is seamless to the building occupants. It is a fraction of the cost. And quite frankly, most of the OEMs didn't even know we did it. So that's the path we did. So in essence, the way we looked at it is one ring to rule them all. And so the journey for us started with building our requirements, and this is deciding what do we want to be when we grew up, what reporting did we do when we were a 5 million square foot campus that made absolutely no sense now. And it's aggregating all that. Then I went around the world, some physically, some virtually. I spoke to all my tech peers to say, who's doing stuff in this domain? Who's doing this stuff in smart buildings or analytics? And after talking to universities, national labs, my tech peers, the answer came back that nobody was really doing it at the level that I thought was out there. In fact, my tech peers said, this sounds wonderful. When you figure it out, let us know because we think it's really cool. So I didn't have this beacon to point at, or our team didn't have this beacon to point to say, they've got it figured out, we'll follow them. So the challenge is we had to kind of create this as we went along. And I want to tell you about a typical day for me. So in the facilities management world, everything's great. We're having a wonderful day, the good weather, doing our maintenance, but then things go bad. So for example, the example up here is a 30,000 CFM air handler unit. So an 85-ton unit. And the way that building management systems work today is everything's fine, your hair's on fire. So for example, we get an alarm, it says, okay, low temperature alarm, everything goes to critical, everybody grab your trucks, your tools. The indoor air is 16 degrees C, so I'm getting a call from all the executive admins, and we're wasting a ton of energy. We're just in a responsive mode. This was our lives every day. This is the lives of facility management, and this is how it goes. And we said, there's got to be a better way. There's got to be a way to step, to know when this has happened. And this is really around the analytics. So, for example, what I want to do is a system starts having issues and starts degrading. I want to catch it early. So at this stage, yeah, okay, so we're wasting energy. We may respond now or we may wait. Starts getting a little worse. Okay, maybe nobody in the building knows it. So this is the value of analytics. So if it's 21 degrees in the building, nobody's calling maintenance and say, hey, there's a problem. It's not an alarm condition, so the building's not telling, the building system isn't saying, hey, there's a problem. But we're wasting energy and we don't know it. And then things get a little worse. Okay, yeah, we want to respond. Still nobody in the building knows it, we know it, but we can respond. And then if we do nothing, then our hair's on fire, and that's a consequence. So we don't want to do it. So what was our situation? We have disparate systems, disparate applications. We couldn't aggregate or overlay. I couldn't compare like-type buildings, like-type systems. I just didn't have a way, labor-intensive reporting. I had a clipboard budget. I never want another clipboard budget again. We actually went around and took readings on critical equipment. So we decided, after doing the looking at this, that we said, okay, maybe the industry isn't ready yet, but let's test it. Let's use our lab as a living lab and really seeing if the technology is there and what we can do. So I started with 56 vendors around the world, got it with an RFI, got it down to 6 for an RFP, and instead of picking one and betting everything on that, we decided to bet to try 3. So we selected 3 vendors on a bake-off. We gave them each a section of the building. So some got new, or we gave them new buildings, old buildings, make sure they had a variety of systems because they had to be able to prove. And it really was around aggregating the data. We also compared software as a service versus on-premise. So if you think of software as a service, one way to think of that is, do I want to insource or outsource my engineering? So some buildings or some companies, you know, the facility manager, facility engineering team, they have to make sure the conference rooms are set up, the kitchenettes are stocked. They have maybe limited time to do the analytics. So there's vendors that you can port the data to, and they'll do the analytics for you. On-premise, and we're in a private cloud, but the on-premise is a way of looking at, hey, we have the engineering staff ourselves, we can do it. And then the 3 anchors on this was reducing energy consumption, optimizing the building assets, improving labor efficiency. So energy consumption, $60 million, yeah, that's a great target. We own $4 billion of assets in Puget Sound. So if I can extend the lives of these assets, that's real dollars. And the last one is labor efficiency. So we today sit around and we wait for the phone to ring. I want to be proactive, not reactive. I want to change the way we do it and optimize our labor service. So we have three different approaches: fault detection, diagnostics, energy management, alarm management. And for just using an analogy between the difference between an alarm and a fault, and what I showed you was the alarm, your hair's on fire, and the fault. Just using a medical analogy, with an alarm condition, you're in the hospital, you're in the emergency room, it's too late. With a fault, it's as if your physician's telling you that your cholesterol's starting to rise, your blood pressure's rising. It's a precursor to catastrophic event. And we have two different types of faults we look for. We look for when assets aren't running as designed. We look at when set points have been made outside our standard. And the scary thing is here, so if you think of aircon mechanical systems, the moment you install a mechanical system in your building, it does nothing but degrade from that point on. Yikes. So energy management is really looking at your energy, your KPIs. I wouldn't say we were managing our campus by the utility bill, but we were about this close to it. So we spend roughly $180,000 a day on energy on average. And I got the utility bill 60 days later. And I can say, well, 60 days ago, something bad was going on our campus. We should go look at that. What are you going to do with that? So how do you use all this energy data in a better way? And KPIs, dashboards. We're Microsoft. We like to measure everything, KPI everything. And then prioritize and monetize alarms. So this is the network architecture from a high level. So if you think of it, it's building management systems. We have 7. We go down to control panels, energy meters. We consume data from buildings that are 2 years old, buildings that are 35 years old. Everything we're doing here, there was not any hardware installed, there were not any sensors installed. This is a completely software play. We're using the operational data that's coming out of the systems as they were built, as they were put in the buildings, to optimize them. And so we pull in weather data because we want to normalize against weather. And our utility payment because I'm looking at rates. Now we don't pay spot rates in Puget Sound. It's a flat rate, but there's a lot of other areas that do. So it'll be an interesting exercise for that. And they're probably moving that way in the future. And then what we do with the data is on the right with the Ops Center. So if you give me a little data, I can tell you a lot. If you give me 12 months of your energy consumption data, and you give me 12 months of weather data, I could tell you, and these are not. There we go. These are two of our campuses, Silicon Valley and Las Colinas. Energy use index is a standard that we can look and see how's it performing to industry, how's it performing to a Microsoft building. Sorry. We can tell you the seasonal variation, so I can tell if you're running the economizers, if you're not, if you're running in constant speed. I can look at a lot of, all right, stop. Look at a lot of data. So from this, I can glean a ton of information, tell you how well you're running your building. And these are just 2 data points. Imagine what I could do if I had real-time data from all the building systems. So we're going to go there. First, I got to show you my pain. This is one of our 7 building management systems. The graphics are cool. I think 1970s, 80s was a good year. If you see the colors and all the different colors around the building, they mean absolutely nothing. I can't tell you how much energy I'm consuming. I can't tell you which buildings are in distress, which buildings are running optimally. It's just a dumb 2D drawing. And the challenge here is, if we have a windstorm, a power event, some type of issue at our campus, we roll trucks. It's more effective for me to have people jump in their trucks, head out, start with the most important building, work your way down, and about 4 hours later, I can tell you how the campus is doing. That's ridiculous. That's not. And that's consistent, not with us, but a lot of my peers out there that manage portfolios. And so this is before, and let me show you now. So this is one of our dashboards, and I tear up when I see this. This is all the disparate systems, applications. Some sit in data centers, some sit in network closets. This isn't aggregated on one dashboard. So what we have here is the top performing buildings. I also have a dashboard that shows the worst performing buildings, but I don't share that. And by the way, if you work for me, you don't want to be on the worst performing buildings, just so you know. We have a BPI, or Building Performance Indicator. If you know what a PUE calculation is, that's kind of what we're using for this metric. So it's the total load of the building divided by plug load plus lab load. Little arrows up there go up or down each week depending how the building's performing. At this particular day, it was running at 64 megawatts. So I can see the demand of the campus at a moment. And that makes sense for working with utility demand response, and I'll talk about that in a little. The orange is consumption, the blue is weather. I can look at the campus, I can zoom in, zoom out, how we do last month, last week, overlay it, seasonal variation. I can come up with an energy signature, meaning I expect a building on this weather day with this to perform within this boundary. And when it doesn't, flag it. So this really is all about energy management. And it's good and it's powerful. If you see the circle on the right, this is how we think about our energy strategy. We think of base load, plug load, lab load. So base load's core and shell, plug load's people, and labs is the power for the labs. The mechanical for the labs is captured in the base load. And each of these segments, I can go into them and tell how we're doing. So this is last week, this is the plug load, this is people. So Monday was a holiday in Puget Sound, and that's Tuesday through Friday. Can you tell when lunch is? We can apply tactics and look at things to encourage employee behavior, and I can immediately see, yep, that worked, no, it doesn't. So we have 1,000-member volunteers. We call them sustainability champions. And we train them, and their role is to guilt their neighbor into doing the right thing. So do you really need that lava lamp? Take the refrigerator out, and those types of things. Well, when we go across the campus and deploy those type of tactics and encourage behavior, then people can see it. Prior to this, we gave the sustainability champions data once a quarter. Gee, thanks, that's not that helpful. This is a change in that. So I can also go down to every building level. So the boxes on there, the boxes on the top, the 3 on the left are static, the 3 on the right are dynamic. So what type of building, what type of system, what's the square footage, what's the head count, what's the demand, and how is this building performing? So this is energy management. This is manager consumption. And what we found is the ability that we were starting up our HVAC, the same time the lab was starting up their gear, the same time that other things were happening. And we were hitting a 3 megawatt spike in some of our buildings. Well, we pay what's called a demand charge, which I believe you pay as well, which is what is your peak for that month? And you have a demand charge. Ours is $3 to $5 a kW. But we were causing what a building would run at 2.2 megawatt max, we were hitting 3 megawatts. We had no idea that we were these added costs we were doing ourselves. So we technically were shooting ourselves in the foot once a month. That is great, and energy management can tell you an awful lot. But let me tell you about the cool stuff. So fault detection, I want to kind of give you a little bit better example of fault detection. So this should sound so simple, and why weren't you doing this before? So let's talk about a fault rule for simultaneous heating and cooling, meaning the mechanical system above us is providing the cool air. You could have half of it shifting, pushing hot air, half of it overcooling to compensate for that, and there's a battle going up there, but we don't know it. That happens all the time. So for this example, when the heater stage is on, whether it's resistive heater or hot water loop, and the damper position that brings in cold water is greater than 40%, and if it happens for more than 15 minutes, flag it. Sounds pretty simple. This is a software overlay across multiple building management systems, multiple vendors that provide these type of analytics. So what points do I need? Just a few points: room temperature, heating stage, and damper command. This is a syntax. We're not writing code. We're using if-then-else statements. And what the value is this, is I have the person who's actually writing our fault rules, and we have about 195 of them for 35,000 pieces of equipment. person writing has been out of school with a mechanical engineering degree for 16 months. So it's not complex, it's not IP, it's ability to create these. We drop these fault rules in the tool and away you go. Well, that's great to know when you have a problem, but how do you prioritize? Well, one way to prioritize is by cost. So we actually can put a cost to every fault that happens across, well, I should say most faults that happen across our campus, to know how much it costs in wasted energy a year. This is fault detection. Let me show you what it looks like. So this is one of my other dashboards. This is what we call our ROC, or Redmond Operation Dashboard. The smart pin's in there, and there's a smart pin on every one of our buildings. There's a legend. So the legend is, does the building have utility? Are the backup generators running? Do I have communication issues with the building? Are there faults and alarms? After a power anomaly or during a windstorm, I can go across the entire campus in 60 seconds and tell you where we have problems. We're not rolling trucks. I'm not coming back 4 hours later. 60 seconds. Then we roll trucks to where we have problems versus trying to find the problems. So from a reliability standpoint, this is huge for me. Better yet, I can dive into each building. And this is Studio C. This is where the Xbox team is. And you see every floor has numbers by it. Those numbers equate to faults, where we're either have equipment not running as designed or where there's set points that are outside our standard. I can dive in deeper, and because we sit in finance, red is bad. So anything turns red is something's going on. This was Sunday. This is a screenshot I took from Sunday. So on Sunday at 12:15, so just after midnight in Seattle time, this terminal unit came on. Shouldn't be coming on. It's a priority 5 space, so it's a very low risk space. And it's wasting $169 a year. Well, $169, Daryl, that doesn't sound like very much. I have 20,000 of these boxes across the campus. And enough of them start running out of spec or out of design, now you're bringing on all your air handler equipment as well. So not only do I have a $169 fault, I have a $50,000 fault. So I can look at it at a building level, which is great. I want to look at it at campus level. So this is, we divide our campus into 3 sections: East Campus, West Campus, Remote Campus. This is just looking at the West Campus, which is, about 60 buildings. And I said, all right, cast a net out there. Tell me everything that's not running as designed. Tell me where all the faults are. And so what did it tell me on Sunday? I have 465 pages of opportunity. Hopefully when Daryl gets back, there's going to be less opportunity there. So I can organize it by fault type. This is where we're applying the syntax, the fault rules. This is what I'm looking for. So a challenge in industry today is, we know what we told the building systems to do, the air con, the pumps, the valves. We don't have positive feedback. We don't know what they're really doing. So what we're doing is, I say, tell me across the CCV leaking. So leaking chiller valves. I say, across the West Campus, tell me all the leaky chiller valves we have. Tell me how much it's costing. That's what that looks like. We can do that, and this was 7 p.m., so this was Sunday at the same time. So all these screenshots I just took the other day. I can look at organizing all these issues by priority of the space. So how we prioritize. So for us, energy is super cheap, 5.5 cents a kilowatt hour. I still pay a lot for it. But what's more important for me than the cost of energy is productivity. So if I have a lab go down or a building go down during ship cycle, I'm going to have a real bad day. So here I can prioritize. If you see they're prioritized by 1 to 5. Priority 1 space is super critical. That never can go down. Priority 5 is my office. So if there's a problem in Daryl's office, he may be uncomfortable, a bit tough. It's not going to, it's not going to impact Microsoft. Priority 2 are labs. So we're going to always address a priority 2 space way before we'll do priority 5. So what you're seeing here is moments in time and being able to have this awareness that we never had before. And that's good, and it's wonderful. And it's lowering our energy costs by 6 to 10%, and it's optimizing our campus. It's doing great. But there's other things that are even more beneficial, and I would say the reporting. So this is one of my favorite reports called the Top 500 Faults for a Given Day. It tells me when did it happen, what was the asset, what was the priority of the space, and how much does it cost me in wasted energy if I do nothing? And on this one, I prioritized it by cost, but we actually prioritize it by the priority of the space. So that third one down, a priority 5 space, that actually wouldn't be addressed. It'd be addressed much later. Priority 2, 3, and 4 would happen first. This is one of the other reports. So this report is looking at one RTU, or rooftop air handler, over a period of time. This report before would take me 4 to 6 hours for our engineers to put together. Some of the building management systems allowed us to do it somewhat easily. Some I could never do it at all. 4 to 6 hours for each report. If I want to run again, another 4 to 6 hours. I have 750 air handlers. I'll never get to the campus that way. Takes me roughly about a minute and a half to run this, and it tells us a ton. So for example, this one's, if you look at, not sure what the pointer is. There's a pointer. If you look at that curve, bell-shaped curve, that's the outside economizer on the air handler that pulls in the fresh air. That's the economizer. What I want to do is stay about 10%. So it's a valve position over time. I want to stay about 10% when it's cold, open up, pull in all that fresh air, and then close when it's hot. Well, what this one's doing is when it's 90 degrees outside, it's opening. Now I'm having to cool air. I should never have to cool. If you know what a duct static strategy is, we don't have one. That straight line on that bottom left, that's a bad. This isn't a lab building, so it shouldn't be running on weekends. So red is weekday, blue is weekends, and it turned out it was running on Sunday. Any mechanical engineer can look at these data points and in 10 seconds say, yeah, you have some problems. Typically, we just didn't have the time to go through. So what we do, we plug in the building, we fix 80% of the faults, we look at how the assets performed over time, and what was surprising to us, well, there was a lot of aha moments. One is, if you're familiar with the USGBC, it is certifies a building on how sustainable it's designed. I'm a big fan of USGBC and LEED buildings. It's taken the industry a lot. But our LEED buildings, the ones that were less than 2 years old, have the nice plaque in the lobby that were LEED silver, LEED gold, were the buildings that had the most opportunity. I couldn't believe that. So one of the reasons why is the commissioning and how buildings are handed over are lacking today. So we use a third-party commissioning agent. We follow standard commissioning practices. It just doesn't go deep enough. So another example, this is building 36. So the bars equate to the number of faults, line equals demand of the base load. So remember, base load, plug load, lab load. So we started connecting this building in November, and we started addressing all the faults about January. So we went from 3,000 faults down to 1,500. What we saw is the energy consumption went down by 20%. This is one of our LEED buildings that I would have never have guessed this. One of our other buildings, City Center, this is the largest building in our portfolio. And this is one of the Bing buildings. And we found 17% of energy saves in 5 days. And there were 3 main drivers. One, this building is fed by one air handler at 600,000 CFM, and the economizers was stuck closed. Building management system says, hey, it's working great, life is good. But we were running all the compressors. That's a huge energy waste. We had leaky chiller valves. And the last thing there is we had a problem with the sewer pump in the basement. In the basement, we have 7 layers of parking garage. So in the very basement of this building, the sewer pump had some problems. So what we did was we took all the exhaust fans in that building and put them to manual to exhaust all the air out of the building while we made the repairs. That was about a year ago. Nobody ever caught that we left it in manual. It was $60,000 ago. So that would be an example of somebody making a set point outside our standard. I also love when my boss calls me and says, it's Sunday at 9 o'clock. I'm driving by the campus and it's lit up like a Christmas tree. What gives? Another example of where either somebody product group requested to have the building turned on for a weekend for a special project. We grant it. And then for the next 6 months, it stays turned on. Nobody goes back and changes it. So this catches those types of anomalies immediately. So how did I sell this? So we retro-commission or tune every building across our campus once every 5 years. So we get a building in, we run it for 5 years, and we come back and we snap it back up. But we only address the large equipment. So we get to about 20% of the campus each year, about 200 assets, so it's the large assets, and save $250,000 in energy. We do this by walking around the buildings trying to find the things that are broke. And we look for what we typically will find, sensor drift and such. And we never really get to that utopia state because we're just snapping it as quick as we can and come back. Well, $250,000 a year for 20% of the campus. What if I could do the whole campus in 1 year? And that's what we can do. So now that I have the information at my fingertips, we don't go parading around the building trying to find what's broken. We know what's broken. That's a huge difference for us. So once we connect a building, it never, if it has a fault or set points, it continues to be optimized. So the punchline was, it replaced our 5-year retro commissioning cycle. So the cycle was once every 5 years. We don't do that. We do it continuously or ongoing. We reduced our energy by $2 million, even the first year. And I sit in finance. You never give any money back, or once you give money back, you'll never see it again. So you better be darn sure you want to give that up. And to pay back in less than 18 months. 18 months in the third lowest energy cost state per unit in the U.S. The utility saw the value in this, and they're actually rebating the software, the deployment, and some of the IT costs. And so the ROA after that, or the payback after that, dropped from 18 months to, how come you didn't do this sooner? So I want to give you some insight of how we think about technology. So this is a fire extinguisher. I have 8,500 fire extinguishers around our campus. And I pay tens of thousands of dollars each month for someone to walk around with a punch card. And some of the extinguishers we have are in confidential areas, and the lab people will take the extinguisher and put it in the hallway. So now I don't have extinguisher in the lab where I should be having it, and it's a violation of code. We said there's got to be a better way. So we took the fire extinguishers, we put them on the network. So the fire extinguisher sensor you see there, it senses if the cylinder has a pressure loss, and if the cylinder is removed, and I don't know why, but people remove the cylinders. And the sensor on the left there senses if somebody puts a file cabinet in front of him and blocks it, and it senses. So any of those conditions happen, it sends a note to security. We pilot it in our lab, in our building, and now it's part of our construction standard. So if you see a Microsoft building going up, this is what we'll have in it. So how did the process go? And this is just a really top level. So we did a gap analysis. We developed our requirements, which are actually to my right, your left. Create our test cases, so we want to test against it, that all vendors could do that. RFI, RFP. My pilot team for 2.6 million square feet or 241,000 square meters was 5 people. The deployment team is 6 people. Got to add a little sometimes. In the deployment is we complete a load sheet, configure at our fault rules, cost savings, algorithms, QA, QC, wash, rinse, and repeat. We can do about 4 buildings a week. So this is my team in Redmond. And if you wanted to see the entire campus, you needed 21 screens across the campus to see every building. And so obviously you can't have 21 screens to watch all the time. Now we only need 1. So not only is this optimizing, I would say before, we were like driving a car without a fuel gauge or speedometer. It wasn't very efficient. Now we have optics with visualization. We're automating the resources. So my team, actually, it's not adding staff. It's focusing staff on areas that matter most. And for before, so if you called maintenance and say, boy, I'm hot in my office, somebody would come out, pop a ceiling tile, look up, oh, darn it, it's actuator, go get the part from the warehouse, come back to your office, make the repairs. A lot of windshield time in that. The difference for us today is I can see when that issue, when that terminal unit or VAV box has a problem. I can tell you how broke it is. We can have the technician stop at the warehouse, get the part on the way to your office, and make the repairs, hopefully before you notice it. That isn't how we did work before. So it's changing how we approached it. So this is our little lab we have, and so we do testing in here. I get to talk about this tomorrow. I'll go a little bit deeper, but I'll say that look at it from a hardware and software perspective here, and what other capabilities we could do. The fire extinguishers in there. So a little about the roadmap here. So we did our pilot for 12 months, and that concluded in December 2011. We selected a vendor, and we're going through the campus deployment now. We'll actually be done this month. One of the other things we're looking at is condition-based maintenance. So right now, we change 26,000 air filters across our campus every quarter because a timer goes off. Well, why? Why aren't we looking at the condition of the system and making the change then versus looking at the timer? That's a huge amount of labor efficiencies, parts saves, and it's the right thing to do. The other thing is, I don't want just a point solution. I don't want just something to optimize our energy. I want an end-to-end solution. So what I want now is we're automating the process. So if a work order comes from a person or the smart building solution, it flows into our work order system, and then it feeds capital planning. Before, for capital planning, the way we would ask for money is we'd look at run hours, we'd look at the age of the equipment, maintenance logs, we'd kick the tires, and tell our finance, here's how much money we need for capital planning. Finance, of course, says, need a little bit more from that. So what other information can you give us? Well, now I can compare systems to systems. We can provide a plethora of information that really helps justify funding. And what I'm working on, hopefully be live next month, is once an asset has a fault for a certain duration, it sends a flat file to our work order system. So I'm actually going to have building assets creating their own work order. I will say with the faults, we've found that 48% of the faults that we find, we can correct in 60 seconds or less. The exhaust fan in the city center building is a great example. That took 10 seconds to correct. 52% of the faults, we actually have to roll trucks. The other thing we're looking at, too, is what you saw is the Redmond Operations Center with the people there. That's going to be evolved to the Redmond Optimization Center, or the Global Optimization Center. So we're actually going to do all the analytics for the company at that one spot. We have the skill set and the engineers, so we're able to do that as a service. There's companies that provide that out there today that will do that service, but this is how we're doing it. Tier 2. So this is, I will never be done. Data is data is data. We have 42 full-service cafes, refrigeration, freezers, pull all that data in. In fact, if you think before, and this is a little sad, I could tell you that we served 642,000 slices of pizza each year. Yet I couldn't tell you how much energy that we consumed till about 60 to 90 days after we finished the year. We were tied in point of cells in the machine. So how can I get as intelligent on the buildings and energy as I am about pizza? And then the last thing is smart grid reliability. So we're working with the university on how do you take a 2-hour power outage down to 2 minutes. And looking at the they're censoring, the metering on the grid. How do we use the building as a battery? So, for example, the utility, Bill Gates used to sit in Building 8. Bill Gates hasn't sit in Building 8 in several years. Utility company still thinks he sits in Building 8. So that's not good. So how do you have better collaboration with the utility? And I will say the utility that we have, which is Puget Sound Energy, has been fantastic. The way the rebate program works is I send them a report, they send me a check. I really like that relationship. Usually it's a one-way flow. The utility companies are challenged because of what you call M&V, measure and verification. So when you install a frequency drive or efficiency motor, you're giving rebates and it's based on how much energy you save. But sometimes it's hard to pick up, is the building 3% more efficient because you installed this, or is it cooler today than it was yesterday? So it makes it very complicated. But with the level of reporting we can provide the utility, we can show them the faults, we can show them what we're doing, and they can see cause and effect in the utility meter, and we can see it the sub-meter. So it makes a really good way for us to prove what we're doing. And in fact, one of our buildings, we installed a bunch of what we call variable frequency drives. We plugged that building in, and we saw that everything was running at constant speed. We thought, that can't be right. We installed these motors, but we never hooked them up. So that's another example of, and this was 4 or 5 years ago. So we had the rebate money, everybody was happy, but we couldn't even have proved that we were even running them. Now we can. So the cost is minimal. The impact is huge. Solutions today, and I will say all the vendors that we have worked with, we help them improve their product. I'm a really lucky guy. Not many people have a 15 million square foot campus, a living lab, and latitude to try a lot of things. So I dare you to find someone who has a bigger lab than I do. So it's relatively cost. Oh, and so when we worked with the vendors, it was great because we gave them a lot of, working with them, we gave them a lot of insight. In working at Microsoft, you're expected to be innovative. And so when I say that, I say, I didn't want something that was highly customizable. I want something that was configurable. So that was key to us, and that's what we're seeing here. So there's solutions out there. It's very efficient to spend. You can act on this very quickly. So my last comment I usually say is, what are you waiting for? So with that, I'd like to wrap, and I don't know if we take questions or not. Anybody have any questions? Yes, sir. So the question is, are we seeing consistency, of paraphrase it, you're seeing equipment or manufacturers consistently that has a lot of faults and we'd either have addressed it with them. So was there things that we saw that we didn't see? The answer is yes. So we actually had a company called Naylor. They have terminal units that the actuators were failing a ton. And we didn't realize this in our standard system because we're so myopic. We're at the building level. We didn't realize that there was a consistent problem happening. So we actually brought Naylor and said, hey, guys, guess what? We're going to talk to us. And I would say this is a tool. And if you have strong teams and great tools, great. But if you're missing one or the other, you're not going to be as effective. And this is the value of us. So on top of looking at that, it provides capital planning. Even how we design our buildings today. So we talked about commissioning being a little bit of a painful process before. This is our commissioning agent. So the developer, contractor, the building yours, when there's faults, when there's no faults, great, it's my building. So we're actually changing how commissioning happens at a campus level. Thank you. Thank you.